guys.
So last week we were talking about NodeRED. Pooja showed us how to put together a nice NodeRED flow, and we flew a Tello drone.
Right.
And this week we're gonna try and get this cool car streaming video and detecting objects.
Yep. So how are we going to do that exactly? I know that you created this really awesome tool to actually detect objects, so I feel like you should walk us through that.
Right.
Yeah.
It's exactly what I'm going to do.
Yeah.
We in an older video we went over cloud annotations before and how to train an object detection model. We're going to do that again today. Today actually, or this week, I pushed cloud annotations 2.0. So it's different, fun, fancy, cool, and let's just dive in. All right. So to use cloud annotations, we just need to go to cloud.annotations.ai, and this is the nice landing page. And then we can continue with IBM. This will let us log in or create an IBM ID if we don't have one already. And this gives us access to object storage buckets where we can store all of our data and annotations. So I'm going to go ahead and continue with IBM. And then if you've never used IBM Cloud before, you can go ahead and click the Create an IBM ID. I'm going to go ahead and log in with mine. So actually I'm going to log in with a fake one.
Yeah, so you'll probably need to go ahead and create an IBM Cloud account first, right?
Right.
And then you should be able to
And then
use this tool.
It'll redirect you back in.
Right.
So I'm just going to log in. Oh no. I'm going to try this again with a different account. There we go. All right, so when you first log in, it won't show you this probably. It'll probably show you something similar that says account not activated. And to activate your account, all you need to do is log into IBM Cloud, and it'll send you an email with a little code that you click on, and it'll activate your account. And then it'll take you to this page that says no object storage instance if you don't have one yet. So in order to get an object storage instance, all you have to do is click Get Started, and it'll open up a page. Or it'll log you out. Oh, there we go. Oh, I might have been logged into my other IBM. Okay, makes sense. So anyway, it'll bring you to a page, hopefully, that looks like this. And it'll give you options for creating a cloud object storage. And we're just going to be using the free tier. It gives you 25 gigabytes free, which is plenty. And then log in or create your account, and then you should be good to go. And then I'm going to go ahead and just log back into like my actual account that has my object storage instance. Sorry for all this going back and forth.
Right. So if you guys were to do this, I think you just need to create one account and then go create, I guess, a cloud object storage instance.
Right.
And you should be able to use cloud annotations once you do that.
Yeah, it'll be much more streamlined. I'm just like going back and forth between accounts just so you can see what it looks like the first time you go in. All right. So the next, like once you like actually have your account and all that stuff, all you need to do is log in, and then it'll redirect you back to the tool. And then all of your buckets should show up. You probably don't have any buckets yet. So I'm going to create a new bucket, and I'm going to do so by clicking this Start a New Project. And then we can name our bucket, and the bucket can be named anything you want. It just has to be unique across IBM.
Yeah.
So sometimes it might be hard to find something that's unique. So I normally like include my name or the day.
I know you have like cute dog videos too.
Yes.
Is that here,
Oh, that's now.
That's now. Okay.
Yeah. So I'm just gonna call this
Okay.
Nick, the date, and dogs. So that shouldn't really collide with anybody. And then we have two options. If you've used cloud annotations before, it's the same thing. Classification is just if you have a photo and you want to classify the photo in general. So if I showed you a picture of a dog, it would be labeled as dog.
Cool.
Localization, I can show you a picture with dogs and cats in it, and it could tell you where all the dogs and cats are, how many dogs, how many cats.
Right.
Much more like fine-grained information we can get.
Cool.
And the trade-off is it's a lot easier to just label photos in general versus like going in and like labeling them like very fine-grained.
Right. And I feel like for, especially when you do have videos, I think having like a localization model is like way more accurate because then it'll show you exactly where your objects are versus what the big picture is overall.
Right. And then once we create our bucket, we'll just have this nice empty bucket page. And we can upload videos or images. If we upload a video, it'll split it up into frames. And I have this nice puppy video that you probably saw when you first logged in. And it'll probably take a couple seconds while it's cutting the frame up and turning it into all the frames. And then the photos will start loading. And then so all you need to do to start labeling this, you can first probably create a label. So I'll make a label dog. And now we can just start drawing rectangles around the dog. And so ideally, we want to make about at least 50 of these boxes will give us an okay model. Obviously, the more information we give the machine learning model to learn, the better it will be. So the more the merrier. I think if you can get like 200 of these boxes, you're going to be pretty good to go.
So does this mean that if we were to give the model, if I brought my puppy in and we showed, to video streaming of it, would it be able to recognize my puppy as a dog? Or
with this model that we're training right now,
right.
Probably not, depending on what your dog looks like.
Right.
So right now I'm only labeling this like one specific breed of dogs. So the model doesn't really know what it's supposed to be learning. It just knows that whatever we put in this box is a dog.
I see.
And like it'll probably just pick up like this specific breed of dog.
Okay.
So if your dog looks radically different than this dog, it probably just doesn't know what is this creature.
Right.
So
we'll probably have to put in way more pictures and build that up a lot more.
Yeah. So yeah, if you want to do just dogs in general, you want to have like a nice variety of breeds. You don't need every breed. It'll eventually kind of get that like, oh, if it's like kind of a four-legged creature with a tail, it's probably a dog.
Right.
It might also start thinking cats are dogs.
Right.
And that's just you'd want to have cats in your data set as well.
Is there a way to categorize or build like different categories using this tool?
Yeah. So if we wanted to like also categorize cats, we would just make a cat label, and then we would start labeling things as cat. So I'm just going to call this dog a cat now. And we could also have like, oh look, there's a nice little flag in the background. We can label that too. And let's label the clouds. Why not? some nice big clouds up there. And then let's label this flag. And I'm going to still call this a cat. And then yeah, just keep going through, labeling all your photos. And now we have 4 classes: clouds, flag, cat, and dog. And then that's however many boxes we've drawn. And again, you want to try and get like each one of these up to like 50.
Okay.
And then once your model, or not once your model, once you're satisfied with the initial images, you can either export these annotations, like if you go to File, you could export it as YOLO, CreateML, or Pascal VOC. These are all kind of pretty popular annotation formats.
Mm-hmm.
So YOLO, you might have heard of like the YOLO object detection model.
Yep.
That's the format that uses.
Right.
Pascal VOC is also a popular one that can train with a different variety of model trainers.
Mm-hmm.
And then there's CreateML, which I don't think it's out yet. It's coming in the new macOS update. So if you export to CreateML, you can use the CreateML tool and just drag and drop these annotations into there, and it'll train the model for you.
Nice.
But what we're going to be using is a tool called Cackley. So we don't need to export the annotations. It'll handle all of that for us.
Okay.
It's actually going to mount our object storage bucket to a machine learning trainer with GPUs. So it's all very fast and fancy.
Okay, cool. So what do we need for that to use Cackley again? Because I know we have the cloud annotations bucket,
Right.
and we got that through the IBM Cloud.
Right.
But would we need another service or anything?
Yeah, right. So
Right.
there's another service called Watson Machine Learning.
Mm-hmm.
And that's what's going to do the training for us. We'll give it a zip file with all of our training code, which you actually don't need to worry about. There's a default one selected for you. But if you wanted to get like nitty gritty and like actually create your own training code, you could just supply that zip code or zip file, and you give it credentials to your object storage bucket, and then whenever it starts training, it just looks in that bucket, trained off of those photos.
Cool.
So actually, I went into more details on how to train in a previous video, and that hasn't really changed too much, so I won't really talk about it too much. But all you need to do to get cloud annotations, it's part of, it's an NPM package that you can install globally. So I'm just going to npm install G for global, and then cloud annotations. And this will install the Cackley program, which just stands for Cloud Annotations CLI.
Mm-hmm.
So I'm going to run that. It'll install it, and then we can just use it by running Cackley and then some commands.
Cool.
So I'll just wait for that to download. And so what this gives us the ability to do is all we need to do is run Cackley train, and it'll ask us for all of our credentials, and it will just submit the training run. So if you run Cackley, it'll actually give you a list of all the commands. So Cackley init, that will ask you all of the questions like with a little bit more detail. Then Cackley train, it will actually train it, and then logs in progress will both kind of give you like diagnostics on how your model training is going, when's it going to finish, all that kind of stuff. And then once you're finished, you can run Cackley download, and it'll actually download the model for you.
Nice. That's pretty neat. So like, you just have this one tool that you pretty much spin up, and you can take the model that you just annotated and have it trained right there in the CLI.
Right.
So yeah.
Yeah, awesome. And then there's no setup. You don't have to like set up Python or install TensorFlow, all that kind of stuff. It's all happening on a GPU, so it's fast and hopefully no errors.
Cool.
So yeah, I'm not going to go into details on how to get credentials and stuff. We have another video on YouTube. Please check that out. It goes through all of those hurdles. Today, I just want to focus on how we can get this model to run with our Raspberry Pi streaming. So let's pull this up. So here is my Raspberry Pi. I am just using screen share to, I guess, not really SSH, but go into the Raspberry Pi. So this is not on my computer. This is on the Raspberry Pi right now. So we're going to be using NodeRED.
Yeah.
And NodeRED comes installed on the Raspberry Pi already. So if you go under like programming, you should see this NodeRED here.
Yeah. So I think we talked a little bit about it last week. So it's one of those tools that's really great for prototyping, and IoT devices is like the best use case. So it was really great that we were able to get NodeRED controlling the Pi. And so I think in general, with the Raspberry Pi Foundation, they're such a great partner with NodeRED that it's just like, I think they have it already pre-installed. So if you guys ever try this at home, I'm sure you'll be able to use NodeRED pretty easily, especially when you're using a Pi.
Yeah.
So.
Oh, yeah. So and then to start NodeRED, all you need to do is just type NodeRED, and it should start it up for us. But before I do that, I want to talk a little bit about ffmpeg. So this whole video streaming setup is going to rely on ffmpeg, and it should come installed on the Raspberry Pi. I think it came installed on mine.
Right.
It didn't come installed on hers, so you might need to install it. You can check by running ffmpeg. If it prints out a bunch of stuff like this, you've got it. If it says command not found or something along those lines, you need to install it.
Yeah, you might need to install it, and
it might be chaos.
Right, but it might take you a really long time, but it's working. So if you are like a few hours into the installation, don't worry, it'll do it. So
hang in there.
Hang in there, exactly.
Yeah, and then so another thing that you need to do. So I actually have like this. There's a camera plugged into the Raspberry Pi. I don't know if you can see that, but in order to activate the camera, I think you have to run like sudo raspi config.
Yes.
Oh, there might be like a dash.
Yeah.
Probably should have looked before I tried to run this. Oh, I put it in the wrong space. Yeah, there we go. And then use the arrow keys to get to the interfacing options. And then it'll give you a bunch of options. We're going to use the camera, so we need to enable it. Would you like to enable?
Yes.
There should be a. It didn't show up, but there should be a little yes or no selection underneath. But our camera is enabled. Hopefully I didn't disable it. Okay, the camera is enabled. Oh yeah, that's okay. All right, and then we can just click finish, and now our camera should be working. That should be basically the only setup you need to do to get the camera working and have ffmpeg installed. Then NodeRED specific and with this model. So I pulled the model into the Raspberry Pi. It's in this folder called Model Web, which gets downloaded from the terminal using the Cloud Annotations. So you can actually run Cloud Annotations on the Raspberry Pi as well and just download it here, or you could copy them into the Raspberry Pi from your computer to the Raspberry Pi.
Right.
Your call. It just needs to be on the Raspberry Pi. And then, since we're using NodeRED and we need to serve this model to our interface, and we can do that using some NodeRED settings. So I'm actually going to open up the file explorer just so it's a little bit easier to handle with like a GUI. there should be this NodeRED folder in your Raspberry Pi.
Yep.
You might not be able to see it. You might need to click this Show Hidden Files. You can get there by right-clicking. And then we can open it up. And there should be a settings.js file in the Raspberry Pi. There might not be. If it's not there, just create one. And then I'm going to open this up. And it's exporting this object with these three options.
Right.
If the settings.js was already in there, it will be like this really big settings file with a bunch of things commented out.
Okay.
We just need to uncomment these or add them. So the first thing is this HTTP static. And what that does is we can specify a path that it'll like statically serve our assets. So if you go to the website and you type in like the address of that file, it'll actually open that file for you. And I just pointed it to the root directory of the Raspberry Pi, which you might not want to do because then that kind of gives access to that folder for anybody that goes to your website. I would probably make a separate folder like called static and only put folders in or put files in there that you are okay with other people seeing.
Right.
And then when we set this HTTP static folder, we also need to set this node root and HTTP admin root. And the reason for that is because anytime we go to like the root of our website, it'll just be these files that we're serving. But if we need to get to like our dashboard editor or we're making API calls, they actually need a separate root, otherwise they'll get overridden by the things that we're serving. So I made a thing called editor and API. You can name these anything you want. The main thing is that this admin root, whenever you open up the NodeRED interface, you need to go to like the localhost 1880 / whatever your admin root is. So for us, it'll be /editor. But yeah.
Okay. Yeah, I think that makes sense.
And then API is if you make API calls in your NodeRED, it'll be making it to this API endpoint. So that should all that you need to do. Then I'm going to open up the terminal again. A little laggy. Okay. And then all we need to do is run NodeRED to start NodeRED. And I actually put together the flow, so as soon as I run that, it's going to start streaming from our Raspberry Pi camera. But I'm going to open up the internet on the Raspberry Pi so we can actually see the NodeRED flow.
So we're already seeing that data streaming in.
Yeah. Yeah, so immediately when you start up NodeRED, if you have the flow in there already, because I already built out the flow.
Right.
So now I'm going to go to our localhost 1880. And normally you just have to go to that, but since we set the admin path, we need to go to /editor. Sorry, the font is extremely small. And then we should see our flow in here. And I'll go over that a little bit.
Okay.
So we have this ffmpeg stream node. And it's connected to this set message topic. And it goes into this join and this template thing and out into this HTTP thing. And so what's happening here is when we start ffmpeg stream, it'll actually give us like this unique stream ID.
Right.
And then we have this like get API. Yeah, see how this is like /API dashboard? That's because our node root is API. And then, so this is just like if we go to /API dashboard, we'll actually see our website. And we're setting a topic so that when they get joined together, it'll get joined into like an object so that we can send both of them into this template. And then inside this template, this mess. In this little tiny window, if I scroll down to here, we have like this WebSocket URL, which is like the host name, which will be like the IP address. And then we have this payload.websocket URL, and that's like our stream ID. And we need to pass that into the player so that it can actually play
Cool.
the video.
So can we see what that looks like?
Yes,
Yeah.
I'll show you what that looks like, and then I'll go into a little bit more detail on like what's going on in the flow.
Cool.
So
By the way, so I think that ffmpeg node, we actually ended up creating that node on our own because
right.
I think with NodeRED, of course there's like all of these default nodes, but for live video streaming, it was really tough for us to kind of like have the ffmpeg server running along with trying to get the website running, and that's why I think building our own node was really helpful because
right.
we could not only take the stream from the Pi, but we could also take the stream from, we have an example where we're going to take a stream from a tele drone. I think we showed that drone last week. So it's really neat. So I think the idea here is that if anyone wants to ever stream or do any video streaming, they don't need to figure out all the steps set up for that, especially if they're streaming with a Pi or a drone.
Right, they just need to drag out
that node. So I think, we'll be publishing a little bit of demos and publication on how you can go ahead and install that node, but you could just do once you have NodeRED installed, you could do an npm install.
Yeah, and it should be in the palette manager thing too.
Right. So, yeah.
Cool. So I'm gonna open up Chrome again. So we need the IP address of the Raspberry Pi so that we can see what's going on from the computer, from our like actual computer. So you can get the IP address by typing in hostname space -i. And so our IP address is 92.36.213.174. So now I'm going to go over in Chrome. I'm going to go to 9.236. I probably already have it. Yep. And then you're going to go to /API/dashboard. And it won't come up because I quit NodeRED. But I should be able to start that back up. It'll start streaming again, and then I can load this page. All right,
Okay,
so it should be streaming. So I should be able to just open up this page, and we should eventually see, us. There we are. So it might look a little laggy because this is on we're like streaming and lots of crazy things.
Yeah.
But let's see. Oh boy, it's really laggy.
Oh, but you can see some object detection happening.
So we have a thumbs up, thumbs down model. Oh wow, it's super laggy. Oh boy. Oh yeah, there we go. Thumbs up. Thumbs down. But yeah, so normally when we run this and we're not also streaming and doing a bunch of crazy things at the same time, it's like instantly fast. Like there's no lag. But yeah, this is fun.
So yeah, right now we have the Pi hooked up to a car, which is kind of cool. So I mean, you can imagine like you could use a car like this and an object detection model to kind of detect like speed bumps or.
Here, wait, can we do like a inception?
Yeah, can we do it? Yeah.
Nice. Oh yeah. Trippy.
Yeah.
But
Whoa. It is definitely trying to detect something there.
Yeah, very fisheye.
Yeah.
But yeah, so we're trying to, we're trying to build a self-driving car. I don't have all the parts yet, and so object detection I definitely think will be useful in detecting people and things like that,
Definitely.
so you don't run into them.
Yeah, and I think the use cases are kind of limitless. I was at a hackathon the other day, and someone wanted to use object detection on a cane to detect, objects for blind people, and like vibrate when there was like some sort of like impeding object. So
Right.
I think, especially, in terms of use cases for video streaming and object detection, I think they're pretty endless. And, we're playing around a little bit with the Pi, and we're going to be playing around with the drone. So, yeah, especially I think we're gonna start. So this the node is up on npm to take, and we'll publish all the flows on a GitHub. So we'll send that info out for anyone who's interested in playing around with this. It's really easy, especially you might not even need to create this because there's a lot of code that we put in the template node. So especially with NodeRED, it's so easy to just import that stuff. So
Right.
yeah.
Yeah, and then again, if you don't want to use NodeRED and just use Node, we also have code for that too. But I'm really excited that I got it working on a Raspberry Pi. I've got like a lot of people are always asking like, how do I video stream on my Raspberry Pi and do object detection and all that kind of stuff. So it's finally working.
Yeah.
But yeah, so basically a little bit more technical background on what's going on inside that node is so this ffmpeg node, it's starting up a ffmpeg process, which is just reading from the Raspberry Pi camera, and we needed a way to stream it to the browser so we can actually see what's going on. And we're using this library called ffmpeg, which decodes MPEG-1, which when I first saw, I was like, why MPEG-1? Why not like, are we on MPEG-4? And the reason is because MPEG-1 is super simple. So some really smart guy out there was able to, actually hand build the decoder, and it's like really old, so there's like no royalties or anything like that, so it's free. MPEG-4 is like apparently extremely complicated to like actually decode, and there's no like really web decoders out there for MPEG-4. Right. So that's why we're using MPEG-1. And then there's like HLS and MPEG-. I think our Twitch stream is probably one of those two, which is it's great for live streaming, but there's like normally like a 5-second, 10-second lag between, which is fine for most things, but when we're like driving a car and we want like instant, it's not gonna cut it.
I remember the first version you were using. What were you using?
I was using HLS.
Yeah, because it was so slow. Like so I think with what we
it's probably about as slow as it was in the video today.
Right, exactly. So I think that was like a big upgrade for using.
Right. But yeah, and then inside of this, we can go back and do this template node. Oh wait, I'm always clicking on the wrong screen. So inside this template node, we are importing. We have two tags. We have the video canvas and the drawing canvas, and the video canvas is what the ffmpeg is like rendering our actual video to.
Right.
And then the draw canvas is where we're drawing the bounding boxes.
Right.
And then we're importing this like CDN, cloud annotations, object detection, and that kind of gives us a small little like wrapper around our model, so it's a lot easier to import and make detections.
Oh, so basically what you're saying is that, like, if I had a model that I wanted to use, if I custom trained that model, I could just stick that model right there, like reference it there?
So right here, where this is object detector, that's the library that we're importing.
Right.
So you just do object detector dot load, and then the address of the model web folder, and then it'll load the model in. And then to use the model, we get this model back, and then you just do like model dot detect, and it'll give you like a list of predictions. And then the rest of it is just kind of drawing the bounding boxes on the photo.
Okay, cool. So it's like basically using the cloud annotation tool, building annotating that tool with the pictures that you want, then training that model, and then taking that model and putting it into the model web folder into your NodeRED flow. Okay. just being able to reference it there. So I guess right now we've trained for thumbs up and thumbs down, but you could technically train for like anything like trees
or cat and
yeah,
dog
dogs
and
or-
flag
yeah.
and cloud detector.
Cool. So that's pretty awesome. So yeah.
It's pretty exciting. Yeah, I think that's all I have. Do you have any other questions?
No, I think like there's a lot of moving pieces here, and it does look like there are a lot. But I think what for anyone who's interested in doing video streaming, I mean, the one big thing that we have going is that ffmpeg node. So, especially I guess we don't even have to worry about that. We could just stick that node in, and it should stream.
Right.
And so, for anyone at home that's interested in doing, what are the few things that they have to really think about when building something like this?
So I guess there's like a million moving parts.
Right.
So what we did here, we did the actual streaming on our Raspberry Pi. I keep putting my hand on the Raspberry Pi, but you can't see me like petting my Raspberry Pi. So all of the video streaming is on there, but then the detections themselves were actually happening on my MacBook.
I see.
So that's like one thing you want to think about is you could be like sort of offloading the machine learning work to something else because the Raspberry Pi itself isn't very powerful. So if we try to do it on the Raspberry Pi, it would not be able to get like that real time.
Right.
So surprisingly, the way to get the realist time is to stream it to something else more powerful. But actually, I bought a Coral TPU that I can plug into this, and then that will give us the option to download the TensorFlow model, the TensorFlow Lite model, and run predictions on that. So we could run that in real time, but then it's using like Python. And then Cloud Annotations gives you the opportunity to download that model too. So that's like kind of one thing you want to think about is do you want to build something that can do it real time like on the device itself, or do you want to offload it to something else that's a little bit more powerful? There's different trade-offs you want to think about. But yeah, and then you also kind of need to think about your model, how you're going to get your data. I think the data is probably the most important part.
Mm-hmm.
You need good data. Most of the models that I make are not good models because they're just me on the webcam doing stuff, but as soon as somebody else tries to use it, it's going to break. So you really want to try and get like diversity in your data set,
Right.
Lots of different types of dogs,
Right.
etc.
Right.
All that
You
kind
want
of
to try
stuff.
to eliminate biases, correct?
Yes.
Cool.
Yeah.
Yeah, this is really cool. It's been a fun few weeks playing around with this stuff, and I think what's next, I guess, for
Sure. So next
Yeah.
week, I think Mofi will actually be back. So he'll probably teach us Kubernetes stuff, his whole shtick. But and then if you guys like, I know this video we're jumping around all over the place. I'm sure you're not really going to be able to follow along very well. So we're going to be writing up a very thorough, in-depth tutorial on exactly all the steps you need to go through.
Yep.
But this is a good kind of frame of reference to see like how it all sort of fits together.
Right, and we'll also be so we'll be creating a GitHub repo with all the tutorials, as well as where you can download the ffmpeg node. And also for those of you who are in the New York City area, end of October we'll be doing live person meetups regarding basically this topic. We'll be talking about the car and the Raspberry Pi, object detection, and then we have a workshop on basically detecting objects using the cloud annotation tools, which for those of you who want to meet us in person and would like to come and learn, we'll be doing that by the end of October, October 28th and 30th. So we have that going. So check out the IBM Developer New York City meetup group if you're in the area, and we will be doing that the end of October, the last week. So, and then, and we'll be publishing all of everything that we've created on GitHub
And we'll re-upload this video to YouTube, and we'll put all the links in YouTube. So stay tuned.
Cool. Awesome. Well, thank you guys. See you. Bye.